So we are in unit 6 now, right? All unit 5 work is due. Unit 6 is where we're at. We are starting polynomials. So make sure you don't got headphones or phones or anything. Don't even look at your Chromebook or anything, because unless you're finishing the test, of course. So all right, well, let's start talking about exponents. So there's rules to exponents, and that's what we're talking about today. First thing we want to know is how to expand an exponent. So right here, it tells us x squared. Do y'all know that squared means something times itself 2 times? So x squared literally means x times x, right? So x to the 3rd power, if I were to expand it like that, would be how many x's being multiplied? 3, right? X to the 3rd power, x times x times x, right? That is an expansion. Cool. All right, and then x to the 5th power, as you can imagine, would be 5x being multiplied, right? And no one has headphones, right? Dang, how did I know? That's crazy. All right, so x times x times x times x times x. 5 x's, right? Cool. And Mr. G, you're not going to make me do it again. Yeah. X to the 8th power, how many x's is that? X times 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 x. That's true. All right, we're doing some notes. So let me get this to you. All right. Let's talk about exponents. So stay with me on this. This doesn't have to be confusing, and it won't be. Follow along carefully. There's some differences here. All right, here. Alrighty. So first thing, we are expanding just like our warm-up in this box. Okay. Now there's two rules here: product and quotient. Okay. Now product is when you multiply, and quotient is when you divide, the answer of division. Okay. So multiplying and dividing, there's 2 rules. So the power rule is off to the right here, the product of powers. And we're going to show the expanded form. So does everyone see 2 squared is 2 times 2? 2's. And then 2 to the 4th power, well, that's 2 4 times. 2 times 2 times 2 times 2. That's a lot of 2's being multiplied. There's 2, and then there's 4, and all together those are multiplying. How many 2's are there? Well, there are 6. Here, focus on that. Well, I'll get you the key afterwards. So it's 2 to the power of 6. Okay? So I want you to notice something. We started with a power 2 and a power 4, and we ended up with a power 6. Notice the exponents did not multiply, right? The 2 exponent and the 4 exponent, 2 times 4 is 8. That's not the exponent we have here, right? So I want you to notice the rule right here. When you have 2 bases that are the same, 2 different bases that are multiplying, you're going to add the exponents. You can fill in that blank right there already. I'm telling you, when you're multiplying 2 bases that are the same, you add the exponents, okay? So I'm going to do these next 2 really quick. 5 to the 3rd power is 3 5s. 5 to the 4th power is 4 5s. How many 5s are there? 1, 2, 3, 4, 5, 6, 7. 5 to the 7. How did I get that? I added the exponents, the powers. 3 plus 4 7. When I have two bases that are the same being multiplied, I add the exponents. Okay, same thing here. A to the third power, a times a times a, times a to the second power, a times a. How many a's do I see? 1, 2, 3, 4, 5. A to the fifth power. But remember, all I did was add 3 plus 2. Okay. Any questions so far? All we're doing is same base, add the exponents. I'm going to let you try these next 3 examples. I'm going to give you 1 minute to do it, starting now. Go. All right, here we go. So this says, example 1, x squared times x to the 9th. Same base, so now we can add the exponents. So the 2 plus 9 gives me what? 11. That makes sense? Same base, multiplying, add the exponents. Same thing on the next one. Now the next one, I know the next one has parentheses, but that still means multiply, right? There's some multiplying, so you're going to add the exponents. So b to the fifth times b to the second power, so 5 plus 2 gives me 7. Okay, what's the most common error you're going to see on this is someone writing b to the 10. You're not multiplying the exponents when there's two different bases, two of the same base being multiplied, add the exponents. Now, the way this gets a little bit more spicy is, what if there's coefficients? So example 3 has an exponent, a coefficient 2 and a coefficient 8. Those numbers are not in the exponents. So we're not adding those. They're down on the base, on the ground floor, as it were, right? So this is normal multiplying 2 times 8. All right. So 2 times 8 is what? 16. All right, very good. So we got 16. Trying to stretch, you know. All right, well, anyways. So 2 times 8 is 16. Now, I got x times an x, same base, 2 different bases. So I'm going to add those exponents. 3 plus 2 is x to the 5. Now that one lone y just hanging out there by itself has nothing else to multiply with, so you just write yourself a y. It just kind of comes down with it, okay? So you just got here and you want to snap a picture of this real quick, you can, because I'm about to move it. So let's look at the next section, which is quotient of powers. Quotient means dividing. So you can see that in the little rule right here. When you have, again, two bases, one on top, one on bottom, that are the same, what do I do with those exponents? I'm going to subtract. So multiplying was add the exponents, dividing is subtract the exponents, okay? Well, let me show you how it works. 2 to the 5 on top means 5 twos, 1, 2, 3, 4, 5. And then 2 to the second power on the bottom means 2 twos on the bottom. So here's the deal. If I have 5 on top and 2 on the bottom, any pairs of 2s are going to cancel out, right? And I'm left with just how many 2s? 1, 2, 3. 3 2s, 2 to the third power. So the way you think about it is same base being divided, subtract the exponents. 2 to the 5 minus 2 is 2 to the third power. The next one, again, the same base on top and bottom. So I got 3 5s on top. I got 2 5s on the bottom. 2 of those pairs cancel out. I'm left with 1 5 on top. Now here's the deal. 5 to the 1 power. If you remember week 1, look above up here. Anything to the 1 power, you just don't write that 1. It's like an invisible 1. Usually you don't write that. So if you write 5 to the 1, it's technically not wrong, but the way you're going to normally see it is just 5. Okay? So you don't need that 1 power. It's unnecessary. It's invisible. Now, last one here, x to the 4th means 4x's over 3x's. 3 of them cancel out. I have 1x left over, which we know is just regular old x. Okay? So what did I do each time when I had the same base on top and bottom and I'm dividing? You just subtract the exponents. Subtract the exponents. All right, so I want you to try these 4. Maybe not all of them. I'll give you a minute again, see how far you can get. Here we go. All right, let's talk about this. Example 1. Do the top and bottom have the same base? Yes, they're both x, right? What do I do with the exponents? I subtract. So top, and let's write this over here. It's always top minus bottom. Don't do it the other way around. Okay, so 8 minus 2 is 6. Okay. The most common error would be people trying to divide the exponents, like 8 divided by 2, and get 4. That's not correct. When you have the same base being divided, you subtract the exponents. Okay. Now, here's where the caveat is. If there's coefficients out front, like right here, we have 4 and 3, just regular numbers in front of the bases, those you actually do need to divide. So like when I see 4 over 3 there, I need to actually divide 4 over 3. Now, does 4 over 3 divide or reduce? Maybe, and hopefully you know by looking at it, the answer is no, but if you wanted to check yourself, you don't wreck yourself, 4 divided by 3, and you click the fraction bar button right here, it doesn't reduce. So we're going to leave it as 4 over 3. I'm going to use this line as my fraction bar. So I'm going to have 4 over 3. That's going to stay there. It doesn't reduce. Now what do I do with the x's? Well, they have the same base, so I subtract the exponents. top minus bottom, 12 minus 2 is 10, right? Now, where do you think I put x to the 10? Top or bottom? The default is going to be on top, okay? So again, when you subtract top minus bottom, whatever you get, put it on top, x to the 10. Cool? All right. So far, so good. What about example 3? So the same base, x and x, subtract the exponents. 12 minus 5 gives you 7. And then the y's, now check it out, y squared and y with no exponent. If there is no exponent, do we remember that that means 1 power, right? 1 power, if there's no exponent. The one thing you don't want to think of, it's not 0 power. It's a 1 power if there's nothing there. So go ahead and write it if it helps you. There's a little 1 here. And then top minus bottom. Y squared minus y1, or sorry, 2 minus 1 is 1. Do I write y to the 1 power? You could, but the best way you're going to see it is like that. Okay? Cool. Now, last one here. Once again, if I have coefficients out front, 5 divided by 25, it would help if I could reduce that. Let's see, if 5 divided by 25 reduces. Click the fraction circle. It does reduce to 1 over 5, okay? So this is my fraction bar, 1 over 5. Now, let me tell you, you don't usually write the 1. Okay, you could, but remember, 1 is usually implied and not written on top if there's going to be variables next to it, and there are. So here we go. I got an x on top and bottom, so I'm going to subtract top minus bottom. 8 minus 3 is x to the 5 power. And then y to the 10th over y to the 2nd power. 10 minus 2 is 8. Okay. Again, you've got to divide the coefficients. This reduced to 1 over 5. Usually you don't write that 1 there. It's kind of implied in front. If you write it, it's okay. Then I subtract the exponents, top minus bottom, of the same bases. Flip it over. Got 3 more little things to cover. Does everyone have these examples? Okay, on the back. This is different. Everyone make a big deal about this. Go ahead and write 1 base at the top. 1 base. Do you see in this rule, there's a to the power of m to the power of n, but there's only one a, okay? This is very important because this is going to get all confusing if you don't see the difference. When there is 1 base at the bottom and then 2 powers, power to another power, in this situation, we're going to multiply the exponent. Okay? So the front side of these notes, for 2 bases that match, that's when you add the exponents. This is when there's 1 base with 2 exponents, you multiply the exponents, okay? So, the expanded form stuff, I'm kind of over, I'm not trying to confuse you. So, just take my word for this, that the base, you multiply the 2 exponents if they're there. So look, x, you got 1 base, you got 2 exponents, 4, and then to the power of 2. So that's when you do 4 times 2. And you get x to the 8. Okay? 1 base, multiply the 2 powers, x to the 8. Okay? Now, this next one, here's where it gets kind of dicey. What if there's a coefficient? You'll see this 3 out front. but it's in the parentheses. So when you third power this 4, you're going to multiply those. But you also have to cube the 3, okay? So this cube is going to apply to this coefficient 3. So it's going to have 3 cubed. And then I'm going to have x. And then what do I do with 1 base, power to a power? You multiply those exponents, okay? Now here's the question. What is 3 to the power of 3? 3 cubed is not 6, and it's not 9, okay? A lot of people just think it's multiplying. It is 27. 3 to the exponent 3. Use Desmos to compute if you need to, right? Even to check yourself. So 3 cubed is 27, very good. So this is going to give me 27 for my coefficient. And then, again, 1 base, power to a power, multiply 4 times 3. That's going to be x to the 12, okay? Well, let's do some examples here. Example 1, 1 base, an exponent to another exponent, a power to a power. Like we said, 1 base, you multiply those exponents. So 3 times 2 is 6. The most common error would be someone writing x to the 5th. This is not the situation where you add, because this has 1 base. Okay. Now here, on example 2, once again, this 5th power has to apply to this coefficient too. So it's 2 to the 5th, and then we have 4 times 5 and 2 times 5. Now, 2 to the power 5, or 2 to the 5th power, is not 10 at all. You're going to have to, again, use Desmos to help you out here. 2 times 2 times 2 times 2 times 2 is the expanded version, but 2 to the 5th power is 32. You're multiplying it each time. All right, so 32 x to the, so 4 times 5 is 20. And then y, 2 times 5 is 10. Cool. All right. We got a couple more rules here. This next one can be a little confusing, but stick with me here. What if you have a negative exponent, okay? So watch this. If it's negative, all it does is make it hop across the fraction bar. If you have a negative on top, it's going to jump across the fraction bar to the bottom. If you have a negative on the bottom, it's going to jump across the fraction bar to the top, okay? So I want you to see this here. This negative came to the bottom and became positive. This negative on the bottom came to the top and became positive, okay? And it says it right here. If the negative exponent is in the top, it moves to the bottom and becomes positive. If the negative exponent is in the bottom, it moves to the top and becomes positive. Okay? All right, now check out this example. 5 to the negative 3 power. So here's my fraction bar for my answer. When I see a negative exponent, it has to flip to the other side of the fraction bar. So right now it's on top, so I'm going to get rid of that negative sign and move it to the bottom underneath 1. It has to be underneath something, so if there's nothing on top, you got to put a 1 there, okay? When you see a negative, you move that term to the bottom If it's already on the bottom, you move it to the top and remove the negative out of the exponent, okay? Same thing here. I see a negative exponent. Basically, you don't want negative exponents. So you're going to have to move it across this fraction bar. So now it's going to go to the top and become a positive exponent. And it would be over 1, but usually we don't write the over 1. It's kind of implied, right? So again, this is the part I think we're going to forget the most because we're in a lull in these notes. Some of us look like we're about to fall asleep. So hear me say this again. When there's a negative exponent, you can remove the negative, but you got to flip it across the fraction bar. Okay, last thing. This should be pretty straightforward. Any non-zero number with an exponent of 0 equals 1. That's it. Think of a number. Any number to the 0 power is 1 for sure. So example 1, 7 to the 0 power, well, that's 1. Okay, and it's also up here on invisible map. Look. Actually, yeah, it is right here. Boom. Anything to the 0 power is 1. All right. Whenever anyone tells you you're a 0, just tell them, no, I'm to the 0 power. I'm number 1. Right? Hit them with the dab. Okay. Well, anyways, now here's the only thing that's a little weird. What if there's what if there's a coefficient? So look, 3 times x to the 0 power. What is x to the 0 power? 1, right? So this is basically 3 times 1. What's 3 times 1? 3, okay? So again, what did we do? Anything to the 0 power is 1. Just remember, if there's a coefficient, you got to multiply it, okay? So I'm going to pass out your assignment based on this, okay? I know there's a lot of notes, but we got to learn these properties to move on with the rest of Unit 6. Here we go.